Hi, welcome to 6.2, similar figures in Math 10-3. In the last section, 6.1, we examined when two shapes are similar. There was two big ideas that we had to remember. Those two ideas are the sides and the angles of the shape. Now, in order for two shapes to be similar, the sides have to be in proportion, and basically they have to have the same scale. So if one of the dimensions was multiplied by 2, all of the other dimensions have to be multiplied by 2. Okay, you can't just start multiplying things by different numbers because then shapes would get distorted. It's kind of like when you're resizing an image on a computer. Say you had to do like a profile pic. And in a profile pic, if you're trying to resize the image might look like this, and then you would grab with your mouse down at the corner, and it looks like an icon like that. And what it does is it locks the perspective and keeps the shape looking normal. Now, if you grab just the side, it looks like this. And then you can like pull it left and right and make it fat or skinny, or you grab from the bottom, you can pull it up and down to make something look like really tall or really short, but it distorts it. So what this really is, this 6.2 and 6.1, is just keeping your profile pic looking normal. And in order to do that, you have to use the correct proportion. And what that comes down to basically is a scale factor. And a scale factor is just a number that you multiply by to make things bigger or smaller. And the other thing you need to know is that all the angles have to stay the same, otherwise you don't have the same shape. Okay, so if a triangle all of a sudden became a square, like obviously it's not the same shape because it's got different angles. Okay, so before we get started, I'll just get you to write down one thing. Scale factor, if it's less than 1, bigger than 0, example 1/2, then your shape will become a reduction. The new image will be a reduction. If your scale factor is bigger than 1, for example 2, then you get what's called an enlargement. You want to make the shape bigger. So basically, if you see fractions like this for the scale factor, then your new image will be smaller. And if you see scale factors that are bigger than 1, then you will see an enlargement for the new shape. So let's start with number 1, build your skills. So Pierre drew 2 regular hexagons, which is just a 6-sided figure with all the sides and angles equal in length. Are the 2 hexagons similar? Why or why not? Yes, they are. Since all sides are equal, they will have the same proportion to the original shape. And as well, all angles are still the same. So when you're trying to decide if two shapes are similar or not, you always just need to check that the sides are in the same proportion and that the angles are the same. So that's the check that you need to do. So if Frank, number 2 here, Frank enlarges a photo to poster size, the original photo is 4 inches by 6 inches, so let's just sketch that. Okay, so we have the photo sketch on the page, and we want to compare it to the enlargement. And the enlargement is 1 meter by 1.5 meter. So sketch that in, and you just have to be mindful of where you put the 1 and the 1.5, because 4 is smaller than 6, so then, and 1 is smaller than 1.5, so that helps you figure out which ones are corresponding to each other. Okay, and we always put the model over the original in our ratio, and the model is always the new shape, and the original is always the old shape. And you got to do the dimensions one at a time. So I'll start with 1 and 4, and we'll compare it to 1.5 and 6. And what we need to do is check if they're equal or not, and that's the key right there. So you have to check if the fractions are equal, or in other words, are the proportions the same? And the easiest way to do this is just to check the decimal. So 1/4 is 0.25, and 1.5 divided by 6 is also 0.25. So yes, the angle, or pardon me, the sides are in proportion. And the other thing you need to do is to check the angles. So you can see that the original shape's a rectangle and the new shape's a rectangle. So all the angles are 90 degrees and they're all the same. So that's the other check. You have to check two things. Are the angles the same, and are the sides in a proportion? And we've done that right there and right there. So you always have to do that when you're trying to see if two shapes are similar or not. Okay, let's check out number 3. And this person says that the two rectangles are not similar. And is she right? So what she's done here is she's matched up 60 with 50 because they're both on top. And that's a common mistake. What you need to do is match corresponding sides. And sometimes if there's been a rotation, so you can see here that the short side, you can see the short side 30 and the short side 60 right here. This one's on the side while this one's on the top. So, you know, it's easy to make that mistake. Okay, there's been a rotation that's happened. Imagine you have to rotate this shape. Okay, so another way to easily spot that is, you know, the size. 30 is smaller than 50, 60 is smaller than 100. So 30 goes to 50, or goes with 50. Oh, sorry, my bad. 30 goes with 60, and 50 goes with 100. Okay, so what we need to do is put the model on top of the original. And in this case, I'm not sure which one is which, but doesn't really matter. Let's call this the new and this the old. So the model is always the new thing, so we've got to go 30 dividing 60, and we have to check, is that the same as 50 dividing 100? You go to your decimals and you see that 0.5 is equal to 0.5, and so yes, they are the same. So one of the checks is good. The sides are in proportion. So the sides in proportion. Now the other check is the angles. Are all these angles the same? 90, 90, 90, yes. 90, 90, 90. So when you compare corresponding angles, they're also the same as well. So angles are the same. So we've got our two checks. So yes, similar. Okay, jumping into builder skills number 4. Janelle states that increasing or decreasing the size of a given figure by the same factor will always produce a figure similar to the original. Is it true? And here the answer is no. You have to, you can't just add or subtract the same number. You have to multiply. You cannot just add. So for example, say we had a rectangle that was like 2 by 3. And then what we'll do is we'll add 1, add 1. So then we have 3 and 4. Now when we go to do our ratios, you always have to match up corresponding sides. So 2 goes with 3 and 3 goes with 4. So let's do the ratio. 4 divided by 3, is that the same as 3 divided by 2? And when you go to your decimals, you see that they are not the same proportion, so we say no, not similar. The sides absolutely have to be in a proportion. Okay, the next one, Aiden frames a 24-inch by 36-inch picture with a 4-inch frame. Is the framed picture similar in shape to the unframed picture? Show your calculations. Okay, so we need to get a rectangle down on the page. Get a rectangle down. And then what you need to do is draw another rectangle around it. Is like the picture frame. So is the framed picture similar in shape to the unframed picture? So it's it's 24 by 36, and it's a 4-inch frame, so that means you're going to get 4 that way and 4 that way. So add 4, and you're getting 44 when you add it to 36. And left and right, you're adding 4, so 4 there and 4 there. So 24 plus 4 plus 4 is 32. So now you just check the corresponding sides, and this is going to be, I think, identical to question 4, because you can't just add to each dimension, you have to multiply. So 44 dividing 36, is this the same as 32 dividing 24? Checking my calculator on the decimals, I got a 1.2 repeating and a 1.3 repeating. So like I thought, this no, not similar. Sides have to be in proportion. You cannot just add. You have to multiply. One more to go. Talking about a cylinder having a radius 25 and a height 35. And another cylinder has a radius 30 and a height 40. Are the cylinders similar? Show your calculations. So model dividing original. Make sure you use corresponding sides. So like the radius would go with the other radius. You can't compare the height to the radius, like it's different dimension. So 30 dividing by 25, is this the same as, if I connect the heights, 40 divided by 35? And I don't think this one will be similar. I don't think anyway, because it looks like they've just added 5 to each. But we always check the proportions. 30 divided by 25, 1.2. And 40 divided by 35, 1.14. So no, those are not the same. It's close, but not perfect. So we'd say, are the cylinders similar? Say no, they are not similar, because the sides are not in a proportion. Okay, make sure you do practice your skills number 1. A lot of questions are like this on the test, where they give you a scale and they give you one of the other numbers. Just use cross multiplication to solve. I'll get you started here. 2.5 centimeters for every 500 meters is equal to, they want 12.5 centimeters. You must solve for x meters down here. Cross multiply. Even looking at number 2, I'll get you started there. You can see 6 would go with 4. 10 goes with 7. and 8 goes with 5. You just got to keep the corresponding sides together and check all the proportions. So is 6 divided by 4 the same as 10 divided by 7, the same as 8 divided by 5? You have to just physically check those with your calculator. Just go to the decimal and find out. And if they are the same ratio, then the sides are, or then the shapes are similar. If they're not, the shapes are not similar. So not a lot there. A couple more questions to go, and that's your homework for section 2.